So here's another problem. Again, I just want to do one more where we're working in degrees, just so we practice in both radians and degrees. You'll notice this one is no longer linear because we've got some sine squareds here, okay? Want to just remind you, because I am going to have you try to work this one out on your own, but let's work through the first step together. Sometimes people are tempted to divide both sides by sine of 2 theta. Why can we not do that? Think about that. Pause if you need to think longer. Okay, the reason I can't divide by a quantity involving a variable is that I don't know if that thing is 0. And if that thing is 0, I'm not allowed to divide by it. Okay. Looks to me like if sine of 2 theta is 0, that would make both sides equal to 0. That would actually give me solutions. So I would lose those solutions if I divided through by sine 2 theta. So I don't want to do that. What I want to do anytime I have a quadratic is move everything over to one side, set it equal to 0, and factor. Okay. So I'm going to suggest that at this point, you pause the video and do that. Again, these two parts are what the question is asking for. The solutions are going to be what theta is, and I want all solutions, and I want the solutions between 0 and 360. But given that 2 theta is the angle that shows up in the problem, I think it makes sense to start out by finding the values of 2 theta. Okay. All right, so see you in a minute. Welcome back. So I'm going to subtract sine 2 theta over to the other side so that I get sine squared 2 theta minus sine 2 theta is equal to 0. Okay. Now I can factor out a sine 2 theta. Now here, there were 2 factors of sine 2 theta, because that's what sine squared means. So if I pulled out one of them, the other one is still there. Here, sine 2 theta, I factored that out. All that's left is a place holding 1. Okay. So we get sine 2 theta times sine 2 theta minus 1 equals 0. Very important that that's 0, because if 2 things multiply to give me 0, one of them is 0. So I know that either sine of 2 theta is equal to 0, or sine of 2 theta minus 1 is equal to 0. Whoops. Sorry. Sine of 2 theta, and then I'm subtracting 1. So that would be sine of 2 theta equaling 1. So let's start with sine of 2 theta equaling 0. Now I recognize 0 is a very special number. That tells me that I'm looking for quadrantal angles. Remember that on the unit circle, sine is defined to be the y value where the terminal ray of my angle would intersect the unit circle. That happens at these 2 points. Between 0 and 360 degrees, there are 2 solutions, 0 degrees and 180 degrees. Now, 360 degrees would put me back here, but we're not including that. Okay. What's going to happen is we'll get that because when we move to all values of 2 theta, we're going to be adding a multiple of 2 pi to all of these solutions. And so we'll get that by adding 360. We'll get 360 degrees by adding 1 copy of 360 to 0 degrees. Okay. Now, if sine of 2 theta is equal to 1, that's also a special value. That's the biggest that sine can be. That only occurs at the high point right here. And between 0 and 360 degrees, there's only one angle that actually has that value, and that would be 90 degrees. Okay. So if I look for all values of 2 theta, I might notice that these guys are 180 degrees apart. So I can actually consolidate that, and I can just say 180 degrees times n. N's going to, of course, be an integer. 180 times 0 would give me 0 degrees. 180 times 1 would give me 180 degrees. 180 times 2 would give me 360 degrees. And of course, n can be a negative number as well, so I'm also getting negative angles that would land at one of these points. And then for the 90 degrees, It would just be 90 plus n copies of 360 degrees. I would have to add a full revolution to that, because if I add just 180 degrees, that brings me down here where sine is not 1. Okay, excellent. So we have solved for our 2 theta. Now we're ready to solve for theta. I find it helpful to just write these out as solutions. So I've got 2 theta is 180 degrees times n, or 2 theta is 90 degrees plus n times 360 degrees, where of course n is an integer. So to solve for theta, I'm going to divide both sides by 2. So theta would equal 90 degrees times n. Oops, that's a theta. Here I would divide every term by 2. So theta would equal 45 degrees plus 180 degrees times n, where n is an integer. Okay. So this would give me all values of theta. And now, if I want to find the theta values that are between 0 and 360 degrees, I'm just going to list my n's and my thetas. Now, I do want to be careful here, because I want to remember that that was consolidating 2 answers. Because my angle was 2 theta, I'm expecting to double the number of solutions. So I'm actually expecting to get 4 answers. And that's just because this one expression was consolidating 2 answers that I had right there. So if n is 0, I would get 0 degrees. If n is 1, I would get 90 degrees. If n is 2, I would get 180 degrees. If n is 3, I would get 270 degrees. And if n were 4, I would get 360, but we're not including that. So that would be too big. Okay? Just barely, because that's the cutoff, but I get these 4 solutions from that expression. And over here, let's just list our n's and our thetas. Here, this corresponded to just this one solution. I'm expecting it to lead to twice as many, so to 2 solutions now. So if n is 0, I would get 45 degrees. If n is 1, I'm going to get 45 plus 180. That's going to be 225. And I can see if I added another copy of 180, that's going to take me over 360. So these are the 6 values that I get: 0, 90, 180, 270, 45, and 225. Those are the 6 solutions that I get that are between 0 and 360 degrees.